Hello and welcome back to another of my episodes of PS Crafty DIY.
Today I would like to talk about my oscillating sander, which is not in the best shape. It can be an expensive machine, but like with the most, that really depends on your favorite color, branding and what you're willing to pay for it. These are popping on the market priced very differently and are basically the same. They look the same, their specs are the same, and even their parts list and diagrams are the same. Well, I'm a little confused and also a bit tight, so I bought mine second hand for only a few quid. But it came with a fault. When the on button is pressed, you can hear it click. So the electromagnetic switch engages, but not much else is happening. However, if I give it a little nudge, it starts turning, but sounds really rough. Have a listen. Sounds like something is loading the motor, and it actually does that without any load being put on. Still not starting on its own. Okay, let's unplug it and take a look. First we need to remove the cover at the bottom of the machine. There is 11 screws that need to come out. Right, so what do we have here? The power comes in through the switch, then into the board that feeds the motor which operates the machine. Assuming your supply cable, plug, fuse and switch are fine, then first thing we should check are the motor brushes, as these are wearing down with the use of the machine. But what sort of motor are we dealing with? Well, looking at the board we can see 4 diodes connected in a bridge. The outputs are clearly marked as positive and negative. This means this is an AC to DC rectifier circuit and the motor used must be a DC motor. First motor brush looks very reasonable. Its spring operates fine and the brush is not getting stuck anywhere. The second brush, however, is almost non-existent. It is worn down all the way to the bottom, so this will be our problem. But why are my brushes wearing down unevenly? Well, it could be due to insufficient spring loading pressure, or there could be a damage to the motor commutator. And it looks like this is our second problem. As you can see, there are 2 massive gaps between the plates. That would be wearing the brushes down way too quick. And it must have been arcing here, as it's slightly discolored at this spot. The rotor's gonna have to come out and be replaced along with the brushes, I'm afraid. So what if both of my motor brushes and the commutator are fine? Well, your problem could be mechanical, or there could be a problem with the switch or your bridge rectifier. The rectifier can be tested with oscilloscope, but I don't have one, so I'll just use a decent meter. Right, my probes are connected to positive and negative output of the rectifier instead of the brushes, and my meter is set to DC voltage scale. When I turn this on, the output voltage should be relatively stable, and that's what we are looking for. It's okay if it fluctuates by a few decimal places, but if it jumps up or down by several volts, or if the voltage is not there, well, that would not be a good sign. As you can see, my rectifier is fairly stable, but for the sake of few quid and reliability purposes, I'll replace it anyway. Right, let's carry on with the strip down so we can replace the rotor and inspect the rest of the working parts for any mechanical failure. There is 8 screws fixing the drive assembly to the body of the machine, and once removed, the assembly comes out. The motor is fitted with a single drive cock that appears to be driving 2 separate pulleys using 2 separate drive belts. The top pulley drives the output shaft of the sander round, and the bottom pulley is responsible for the rise and fall oscillating mechanism. Look, they are both fitted with sloped cams, and when these cross each other, it pushes the top pulley along with the output shaft up against this compression spring. The shaft rises, but when the cams miss each other, the compression spring pushes the top pulley down and the shaft falls back down. Simple but very clever. So what do we need to look out for in here? See if the whole mechanism operates smoothly, as any excessive friction may cause loading to the motor. You can lightly lubricate the cams and check all bearings. Check the drive belts for wear and tension. We don't want any slip occurring. All looks good, and to be fair, I'm quite surprised how clean it is in here. Perhaps the dust extraction works really well. Right, let's remove the motor. It looks like it's held on by these 4 screws, and the bore is big enough for the drive cock to slip through. No need to take these out, just loosen them off. There we go, the motor is coming off. Just watch the drive belt. The rotor stop bearing is here, right below the drive cock. Right, let's check its housing for wear. Oh dear, it's all made from plastic. If I had to pay 400 quid for this machine, I don't think I would be too impressed. Next step is to remove the bottom cap held by these two screws. These are reaching all the way through the stator and securing on the nylon motor base plate as well. Here we go, the cap comes off. We get a chance to inspect the bottom bearing and see the damage to the commutator a little better. Now we can push the nylon motor base plate off and carefully remove the rotor from the stator. Not much to see in a stator apart from two magnetic segments. Make sure these are all sound and perhaps give them a bit of clean. Base plate comes off and now we can unscrew the drive cock. As you can see, mine is very loose and that's not good, so I'll have to address that. We will also need the bearings. The top one comes right off, but the bottom one is putting up a little fight. Perhaps I should invest into some bearing pullers, but you can't have it all, can you? Bit of loose juice and it comes off after all. The last thing we need to remove from the old rotor is the circlip. Right, here comes a new rotor. Now do you remember when I said these machines come in different colors under different brands and for very different prices? Well, guess what? Their parts come in different prices too. Here is a quote for a new rotor from a supplier that uses blue color for their tools, like mine. And here is what I paid for the rotor from a supplier that stocks parts for orange tools. Marvelous, isn't it? Right, let's put it back together. I'll start by fitting the circlip onto the new rotor, followed by the two bearings. The bottom bearing slipped right on, but the top one is a bit tight, so I need to clean the shaft with 320 grit wet and dry. Well, that's better. Just ensure the bearing sits on the top of the circlip. Next we can fit the drive cock, and to prevent the assembly from loosening under the load, I'll use a dab of low strength Loctite. The new rotor is now assembled, so we can put it back in the stator. The stator has two different notches. The larger one needs to go on the top, as it accommodates the notch on the nylon base plate. The rotor can be carefully guided through, and we can fit the bottom cap next. The notch on the cap matches the smaller notch on the stator. Make sure the bearing is nicely seated there. Now carefully guide the screws through the stator. They screw into the base plate right here. This can be a little tricky as these are constantly being pulled away from the fixing holes by the magnets inside the stator. Try to keep them straight and don't force anything, so you don't damage the rotor windings. Right, let's fit the motor back in. Know that the side of the motor with the single hole needs to be facing up when the motor is fitted. Prepare the belt for the drive cock to come through. Remember, the bottom belt went round on the inside of this pulley, so you can just hold it in place with your finger until you slip it onto the drive cock. The top belt then fits directly on. There we go, push the iron and we can screw it onto the chassis. Make sure it all sits flat and that the bearing is correctly seated in the housing. The fan on the rotor shouldn't be catching. Give it a last once over and it can be installed back in the machine. Now fitting those 8 fixing screws can be a challenge due to tight space, so either magnetize your screwdriver or use a bit of masking tape to help you guide them in. I'll now replace the rectifier. Change the wires like for like, one at a time, and mount it onto the base plate. Connect the ground to the chassis and fit the new motor brushes. Pop the plastic covers on and check operation of both springs. The right side of the motor is positive. And the left side of the motor is negative. Quick check if these are seated right and we can move on to the last piece of this puzzle, which is the bottom guard. Alright, let's see if it works. Perfect! And it sounds much better. What do you reckon? Well, let's see how it performs under the load. Very well, this will be a great addition to my workshop. Just imagine what can be achieved on a machine like that. Well, if you like what you see, videos for these will be coming soon, so please consider subscribing. Or if you have found this video helpful, please give us a like, drop me a comment or share. It helps the YouTube algorithm and it helps me to create more content for you. Thank you all for watching, and I'll see you at the next one.